Across the universe, astronomers are constantly uncovering the unexpected. But in 2019, a discovery shook the world of radio astronomy. Mysterious, ghostly rings, vast circles of radio emission, larger than entire galaxies, appeared in the sky. They didn't match any known cosmic phenomenon. Today, we call them odd radio circles, or simply ORCs. What are these enigmatic structures? Are they relics of ancient black holes, the echoes of colossal galactic collisions, or something even stranger? In this video, we'll explore the history of their discovery, the leading theories that attempt to explain them, and why solving the puzzle of ORCs could reveal brand new physics about the universe itself. Before we begin, make sure to like this video and subscribe to the channel. Your support helps us bring more of the universe's deepest mysteries straight to you. The story begins in September 2019, when astronomer Anna Kapinska, working with the Australian Square Kilometre Array Pathfinder telescope, noticed something peculiar. In survey data, she saw perfect circular shapes, faint, ghostly halos, unlike anything seen before. At first, the team thought they might be imaging errors, artifacts of the telescope. But as more data rolled in, the circles persisted. They were real. And they were enormous. Some spanned nearly 1 million light-years across, dwarfing our Milky Way galaxy. By 2020, the first official paper was published, identifying these mysterious shapes as a brand new class of astronomical objects. Since then, a handful of ORCs have been found, each raising more questions than answers. By 2021 to 2022, radio telescopes in South Africa, India, and Europe confirmed their existence. The MeerKAT telescope in South Africa revealed intricate details, showing ORCs to be hollow rings with diffuse edges glowing in radio light. By 2023 to 2025, deeper studies found ORCs at various distances, some associated with galaxies, others floating apparently in isolation. Still, no single explanation fit them all. When we look at ORCs through radio telescopes, what do we actually see? Each one appears as a faint, circular ring of radio emission. They are not visible in optical light, meaning our eyes, or even regular optical telescopes like Hubble, would see nothing but empty sky. Only radio arrays, tuned to long wavelengths, reveal their presence. Most ORCs measure hundreds of thousands to over 1 million light-years in diameter. To put that into perspective, if the Milky Way were placed inside one, it would fit comfortably with room to spare. The edges of the circles are brighter than the interiors, suggesting that we are seeing a shell or a bubble structure, glowing more strongly at its rim. This is a telltale sign of shock fronts, places where cosmic gas is compressed and particles are accelerated. Interestingly, ORCs are most visible at frequencies of around 700 MHz to 1.5 GHz, the same range used for early cell phones and Wi-Fi. This means that while they are invisible to our eyes, they shine brightly in the radio spectrum. What could create such enormous, radio-bright circles in the cosmos? Astronomers have proposed several competing models, each with its own strengths and weaknesses. Let's explore them in detail. One idea suggests that odd radio circles, or ORCs, form during colossal galaxy collisions. When galaxies or clusters merge, they generate immense shock waves that heat intergalactic gas and accelerate particles to near-light speeds. As these particles spiral through magnetic fields, they emit powerful radio waves, creating the glowing rings we observe. Evidence like the cloverleaf ORC, surrounded by hot X-ray gas in a merging galaxy region, supports this view. Yet galaxy mergers are common, while ORCs are extremely rare, hinting that only a precise combination of conditions, gas density, magnetic field strength, and timing, can create them. Another leading theory points to the ancient outbursts of supermassive black holes. During active phases, these giants unleash jets of plasma that inflate enormous radio lobes far beyond their host galaxies. Millions of years later, these fossil lobes can be re-energized by shocks or turbulence, shining once again as vast circular radio structures. Some ORCs contain compact central galaxies with signs of past black hole activity. However, many show no current activity, and their near-perfect symmetry is difficult to explain unless viewed from specific angles, suggesting this theory is only part of the puzzle. A third idea focuses on the stars themselves. In some galaxies, waves of intense star formation, called starbursts, unleash colossal winds of charged particles and hot gas into intergalactic space. Even after the starburst ends, the expanding shockwave can travel for hundreds of millions of years, forming a vast shell that may later glow in radio light. Evidence from ORC-4 suggests a billion-year-old disturbance consistent with a past starburst. But galactic winds may lack the energy to produce shells hundreds of thousands of light-years wide, and the lack of optical or X-ray emission challenges this model. Finally, some astronomers propose that ORCs may arise from multiple origins. Some may be relics of ancient black hole activity, others the result of galaxy mergers, and still others echoes of long-vanished starburst winds. What unites them is the precise combination of gas, magnetic fields, shocks, and timing. In this view, ORCs aren't a single type of object, but a family of rare, overlapping cosmic phenomena, each one telling a unique story about how galaxies evolve, interact, and release energy into the universe. ORCs remain one of the universe's most mysterious and captivating discoveries. Cosmic circles that continue to challenge our understanding of galaxies and the forces that shape them. To understand ORCs better, let's look at a few specific examples. The cloverleaf ORC. One of the most famous ORCs is the cloverleaf ORC. It's not just a single ring, but a complex structure with multiple overlapping loops. X-ray data reveal hot gas surrounding it, while optical surveys show several galaxies caught in the middle of a slow-motion collision. Everything about the cloverleaf points toward a galaxy group merger as its origin. It remains one of the strongest pieces of evidence for the merger shockwave theory. ORC-J 0219-0505. This ORC is smaller and fainter than most. Its low brightness suggests there may be many more like it, a hidden population of faint ORCs waiting to be discovered. If that's the case, then ORCs may be far more common than we think, but only the brightest ones are visible with current telescopes. The square kilometre array, once completed, could reveal thousands more of these faint circles, completely reshaping our understanding of their population. ORC-4. This ORC stands out because of its host galaxy. Studies show gas features consistent with a billion-year-old starburst event. That supports the galactic wind scenario, at least for this one object. If true, it means that some ORCs are fossil records of violent star-forming episodes in galaxies long ago, preserved like cosmic fossils in the radio sky. What's striking is that each ORC seems to tell a different story. Some scream of mergers, others whisper of black holes, and a few carry the fingerprints of ancient starbursts. Together, they remind us that the universe rarely gives simple, one-size-fits-all answers. You might wonder, why should we care about a few faint rings lost in the depths of space? Because they may be signposts of something fundamental, the fingerprints of forces shaping galaxies and the cosmos itself. So, how do we solve the mystery of ORCs? Astronomers are deploying every tool at their disposal. First, magnetic mapping, tracing the geometry of shocks through radio polarization. Second, X-ray surveys, searching for hot gas that could confirm massive collisions or galactic winds. Third, studying the galaxies at each ORC's center, looking for clues of ancient black hole activity. Fourth, deep sky surveys, using next-generation instruments like the Square Kilometre Array, which could uncover thousands more ORCs. Odd radio circles remain one of the strangest discoveries of the modern universe. First spotted by chance in 2019, they've since become a cosmic riddle, a whisper from the deep past of galaxies and black holes. Are they the dying echoes of supermassive explosions? The shockwaves of colliding galaxies? The fingerprints of unknown physics? Or something beyond all current imagination? For now, the universe keeps its secret,